Hi, my name is Ms. Chen. I currently teach at Colonia High School. I've been teaching there for about 5 years now. I'm also currently a doctoral student at Columbia University for mathematical education. Today I'm going to be teaching you about parametric equations. I believe it's chapter 9 of the book that I will be putting online, student edition. So this comes a little bit after the conics section. So these are the new vocabulary words that you'll be introduced for today. It's the parametric equations, parameter, orientation, and parametric curves. Okay. So you're imagining that a particle is moving along a curve C. So this is actually the curve C that I have here, this pink line that you see right here. This does not pass the vertical line test, which means that it's really hard to write this in form of a function, f of x. So in order to create this line using your graphing calculator or by hand, it's probably best to change it into parametric equations so that you can draw this in terms of time. So for each x and y coordinate, you're going to have to calculate using a specific t. Sometimes I may give you a certain range of t's, or it might be an infinite amount of t's. And t here would represent your parameter. And most of the time it will be in terms of time. That's why we use the letter t. Now, parametric equation, you'll notice that it was one of the new vocab words. It just means it's an equation where x is in terms of time and so is y. Now, in order to draw these curves, these parametric curves, you will have to plug in values of t into the equation for x and the equation for y, and then find and locate the specific point at that certain time. It will actually, here's an example right over here. You can identify the curve just by plugging in certain values of t. And since I didn't give you a specific value of t, you can just start from basically anywhere. So I have here on my table values of t ranging from -2 to +4. So when you're literally just plugging in -2 in for t, so make sure you're always plugging in using parentheses, because when you plug in -2 and you square it, it's going to be +4, and then minus 2 times your -2, and that gives you +4 plus 4, which gives you 8 for my x value. So this is x, and then it's the same thing for your y. You're just literally plugging in that t value, which is -2 in our case, -2 plus 1. Whoops. -2 plus 1, which gives you -1. And you do this for enough t so that you get the basic picture of your curve. So at t equals -2, even though we don't really talk about time backwards, you can kind of see what happens before time 0. In the next slide, it actually shows you the curvature. So I'm just increase the size right over here. So at t equals -2, if I plugged it in for my function x in terms of t and my function y in terms of t, you get 8, -1 as my coordinate point. So 8 on the x-axis and then -1 on my y-axis. So at time t equals -2, you are located at this point right here. Notice this arrow right over here. It actually gives you the direction of your curve. So at t equals -1, you're actually over here. And then at t equals 0, you're over here. And then so on and so forth. You'll notice that as t increases, you're kind of speeding up. Originally you're from over here, but then you went all the way over here real fast, and then it just starts slowing down and then speeding up. Sorry, slowing down and then speeding up right over here. So at t equals 3, notice the distance from here to here. It's a large gap right there. But between t equals 2 and t equals 3, it's a pretty short distance. So you're actually slowing down and then speeding back up. did I skip a slide? Let's see. Oh, this is just confirming the speed of your particle. Okay, so this slide is basically showing you how to change from parametric equations to rectangular. You're probably unfamiliar with the word rectangular, but you've been using it for most of Algebra 1 and Algebra 2. It's basically writing equations in the form of x's and y's. So how do I change these two equations here into x's and y's? Well, first step is to try to solve for t. Pick the equation that is easiest to get t by itself. So in this problem right here, I think I had the original problem on the previous slide. I actually solved for t by getting, by subtracting 1 over, and that's where I got t equals y minus 1. And what you're going to do with this is you're going to use substitution to plug this into the other equation everywhere you see that t. So I have it written down here. I plugged it in. Y minus 1 goes right into this t, and same thing with this t right over here. And when you FOIL this out and simplify, you're going to get y squared minus 4y plus 3. So I just mentioned that this section is usually taught after conics and transformations of conics. So you should recognize that x equals y squared minus 4y plus 3 should be a sideways parabola. And because your coefficient in front of y squared is positive, you should have a parabola that is facing in this direction. Not my best parabola here. Okay. So basically what these two equations do, when you smush it together, you get this, this parabola right over here. And it's going to mark it based off according to t. If you have it written as x equals y squared minus 4y plus 3, you don't exactly know where you are at a specific point. The parametric equation lets you do that. So that's kind of like the pros and cons of parametric versus rectangular. Rectangular, you won't be able to see where you at a specific point. So this is what I mean by, however, it doesn't tell us when the particle is at a specific point. This is for rectangular coordinates. If you change it into parametric, you will be able to tell where your point is at a specific time. Okay, so here are two examples that I would like for you to try out. This is obviously a demo, so I'm going to probably just do it for you right here quickly. Usually I give you more time to do so. So here, this is probably the best equation to get by itself. So if you solve for t, you're going to divide 2 on both sides. And this will be solved for t. So what you're going to do is you're going to plug all of this stuff into everywhere you see the t in the other equation. You're going to get x equals, probably going to use my tablet next time to write this with the neater handwriting. But this is going to be y over 2, y over 2 squared plus 2. You guys are probably familiar with Algebra 2. You just, in Algebra 1, you just square numerator and denominator, so you get y squared over 4, and then plus 2. Y squared over 4 plus 2. Or y squared plus 8 over 4. Okay. So that's one example.